All right, so my name is Drake Recki, and I'm presenting with my partner Ben Zhao um, on examining feature rank and dependency in certain questions in a ASC questionnaire.
Oh yeah, and we worked under Professor Sadigoff.
So first off, I like to start by describing just what ASD is. ASD is a neurodevelopmental disorder which, as the name suggests, is characterized by a multitude of symptoms which are present to varying degrees in each individual. Some of the core symptoms present in people with ASD are difficulties with communication, stereotypic movements, restricted interests, adherence to certain rigid routines, and hypersensitivity to certain stimuli. There are different therapies that can be used to assist people with ASD and make them feel more comfortable interacting with other people. However, in order to acquire access to such therapies, children and adults often need to be diagnosed with ASD, which doesn't always happen, and also may come with a significant financial cost. It's possible that parents might not know the signs of ASD in their child as well, and the older the child gets, there's a higher probability that they'll start masking, which just hiding their symptoms, which can make it more difficult to identify whether or not someone has ASD or not. So it's also important to identify ASD early because the brain is plastic when a child is really young, and potential treatments, when intervened early, can have a greater impact than if they're implanted later. To assist in the diagnostic process, some people have created abridged questionnaires such as QChat-10, which can be used to screen young children with ASD so they can get a referral for a diagnostic exam and then possibly be diagnosed. The QChat-10 is a set of 10 questions that produce binary outputs, which are either 0 or 1. They'll ask something like, does your child look at you when you call his or her name? And you'll rate it from a scale of 1 to 5, like always, usually, sometimes, rarely, or never. And usually the rarely or nevers encode for a 1, and the other values encode for a 0. So we have a binary representation of what the question was. The QChat-10 then sums up all of the question values for a single child, and if they receive a score of 4 or more, they're labeled as having a high risk of having ASD. Along with this questionnaire, there are also other factors that are involved in the data we examined, such as demographic data, sex and ethnicity, as well as certain medical questions, such as whether or not the child has jaundice. But for this analysis, we focus mostly on the questions, the behavioral questions. Essentially, and here are the questions in question.
Yeah.
And we essentially fit a random forest model using these questions, using the binary output, and try to predict whether or not a child was at high risk of ASD using each particular question, and then use the importance feature of the random forest model to determine which questions were more important than the rest, and then perform further analyses from there.
Okay. So as Drake said, we used random forest model and fit it to the 10 question to see like our questions used for prediction of whether the final like screening result was positive or negative. However, like an important step we did is we met with Professor Sadigoff, and he said that the model is deterministic, that we don't even need something as complex as random forest to for predicting, because you can just add the 4 points, the points, and see if they're greater or equal to 4. So instead, this made our like work, our research go in like completely different direction. Instead of using the random forest for prediction, we only use a random forest for the variable importance graph, which actually identifies the relative importance of the question. And then we did chi-square tests based on the like top features. Like we looked at we took bootstrap samples between the high importance questions, and we saw that they're related to questions that are similarly highly important. And then we did chi-square tests for the bottom groups, which also with bootstrap samples, and the bottom questions were also correlated to each other. But so we have like, this was a results from our variable importance graph. So you see that questions 6, 9, 5, 7 are like among the most important. And if we like take a look back into like the questions on the sheet, 5, 9, 6, 7 are kind of related to behavioral traits as well as attention to parents. Like gestures, behavioral gestures are also like a big predictor according to this. So we made some contingency plots. This comes from chi-square. So like the very saturated regions means that there's a strong relationship between the questions. So it shows that these are the five with 7, 6 with 9. So the top questions are really correlated to each other. And then we wanted to see if like the questions as a whole, were they redundant? So we looked at we took like 4,000 samples, bootstrap samples, from the top 5 questions. And then we took 4,000 bootstrap samples from the bottom 5 questions. When we looked at the tests between these two big groups, when we looked at the test between these two big groups, there was no relationship. As you can see, the contingency plot is just like white, like it's not saturated at all. So that means the questions as a whole are generally good and representative, but among the top questions, there's some level of redundancy, as well as in the bottom questions, there's some level of redundancy.
Now, given that questions 6, 9, 5, 7 were most important, 2, 8, 3, 10 were least important, and we see these redundancies among the top 5 and bottom 4 questions, we conclude that there's some redundancy, right? However, there is no redundancy between the top 5 or top 4 and bottom 4, which means that it may be possible to select representative questions from each of the top 4, each of the bottom 4, or maybe develop some more and use that to develop a more efficient questionnaire. Now, I should also mention there are some sampling limitations with our sample. So our data were gathered from a screening app that was developed in New Zealand. So it's from many parents in New Zealand who downloaded the app willingly and most likely already thought that their child was at risk of having ASD. So it's not a random sample of all parents with children, but rather a random sample of parents who think that their child is at risk for ASD. And this is also performed in New Zealand as well. So New Zealand is not too dissimilar from the US and other developed countries. However, it's just important to note that it was done in a single country. Also, these were binary labels, so we didn't have access to the actual inputs, the actual categories. So as you can see here, each question can be answered in one of 5 ways, but we only received a 0 or 1. And it would be interesting to see it'd be interesting to see if a more severe indication on one of these questions is more important than a less severe indication, such as going from never to rarely or from always to sometimes, if that makes sense.
Okay.
Anyway.
All right.